Hello everyone, welcome to my talk, Effectively Finding Vulnerabilities in Web Applications by Debugging the Source Code. My name is Grzegorz Niedziela, but I'm more known under the brand Bug Bounty Reports Explained. I have a YouTube channel with explanations of complex bug bounty reports. I have other media as well, I have a newsletter. My background is being a pen tester, and right now I'm switching from pen testing to doing bug bounty. I'm documenting everything that I learn in my social media channels, and I also have quite a popular series of bug bounty challenges where I challenge myself to spend 100 hours on one bug bounty target, and I transparently show you as much as I can what I reported, what I learned, and so on and so forth. But enough about me, let's jump to today's agenda. First, for debugging, you need to have the source code. So as the first step, we will actually think about when to get the source code for non-open source projects. Then I will show you what debugging even looks like, and I will show you that it's not that hard as you may think. It's surely not that hard as I thought before I started doing that. Then in the third step, I will tell you my approach to when to do static source code review, when to run the application, and when to have a proper debugging setup. And finally, we'll go through an actual bug, how I found step by step an SSRF in a smoke screen tool. And finally, I will tell you where to start reviewing the code and debugging the code, because you may hopefully want to do this after this presentation. So the easy way to finding the source code is just testing open source targets. On HackerOne, there are a few hundred repositories in scope on different public bug bounty programs. Also, there are some organizations that basically have their whole GitHubs in scope, which makes things easier. And personally, I love these programs because it gives me a lot of room for different configurations, for different attack scenarios. Sometimes in a tool you can even create your own plugins and maybe find bugs that are not there if you just don't write your own code. That's one of the XSSs I reverse engineered recently was found this way. So this is the easy way. But it's not the only way, because sometimes for closed source applications, you can also find the source code. And this is not a secret sauce. It won't magically find you a source code of Facebook or Twitter. But Enterprise Search is an application from Elastic. It's not an open source one. It's not on their GitHub, but it's available to install using Docker image. And if it's Docker image, you can also extract contents of the image and analyze the source code. In this case, it's obfuscated, so it's not that easy, but it is still very much possible. So Docker Hub is the first place where you can check. The other one is just having another vulnerability that allows you to download the source code of the application. So XXC, patch traversal. I was joking that when I get an RCE, my black box pen test becomes a white box pen test. But be cautious with this, because no matter if you are doing a pen test or a bug bounty, you probably should have permission to extract the source code. There are also other methods. Personally, I haven't tried all of them, but these come from an excellent presentation by Shaps called How to Do Code Review the Offensive Security Way, and it's linked at the bottom of the slide. And one of his methods is looking at cloud marketplaces. So for example, on AWS, you can start up a machine with a particular software installed on it. And this software may not be an open source, but if you can have it on your own machine, you can also SSH into this machine and extract the source code. Then you can simply contact sales pretending to be interested in buying this software and getting the trial of this software, which will also may give you access to the source code. And finally, you can find freelancers who have access to a source code. For example, if you want to test a WordPress plugin, find a developer on, let's say, Fiverr or Fiverr who can develop integrations with this plugin. Likely this developer will have access to this plugin, which may cost a few £100. And if you ask nicely, you may get access from this person to this source code. Personally, I haven't tried this method, but I saw them in this presentation and I think they really may work. And we'll right now jump into the practical example. I have a very simple Python script here, which takes a parameter. Let's say it takes the parameter from the user, it's untrusted, and then it puts this parameter inside the command execution. This function subprocess popen executes a command, and we have the parameter here. So immediately you probably think about testing for command injection here, and I would do the same. So I created my parameter like this, and let's just run this program, but all we see is hacking alert. So there are some protections in place that are supposed to protect the app from people like me. And of course, this is a very small script. I could manually review it, but let's see how debugging the program looks like. So I'm in VS Code. This is my go-to IDE, and I can honestly recommend it for languages like Python, Node.js, Golang. It works very, very well. And I have Python extension installed because this is a Python script, obviously. And if I want to debug this program, I can open this play button in the upper right-hand corner and click debug the Python file. And we can see that the command is quite different from what I ran previously, but it doesn't really matter. The result is the same. So what is the difference between just running the program and debugging it? I can simply click with my mouse on the left-hand side of the line number, and this red box appears here. And now if I debug the program again, I can do it using F5 shortcut. I see no output here. I see no hacking alert, nor the command execution, and the line is now yellow. What happened is it hit a breakpoint. This red dot, it was a breakpoint, and it means that when the program gets to executing this particular line, it stops, and I can do now with it whatever I want. And in this case, I can select to continue the execution, and it will just return what it returned previously, and nothing will change. But I can also, instead of continuing, choose to step over this function, and what will happen is this execution of line 32 will continue, but the program will stop in line 33, one line later. And in this case, we can see this is an if expression which calls the isSecure function. So I would like to see what this function does. So in this case, I will choose from this menu step into, which means step into the function, and all of a sudden I am inside in isSecure function, and I can see in the left-hand side that the value of the payload is $ID. So this is exactly what I sent as the argument here. I can also evaluate it in this debug console. I can like call functions here if I wanted, but I'm not going to do this. And in this case, it's a very ugly code, I must admit, and it checks one by one if there are some forbidden characters. So I will step over this one, and we can see that we didn't get inside this if, which means that this condition doesn't break our payload, isn't marking our payload as insecure. So I'm stepping over again and again and again, but this time we went inside the if expression. We went inside this block, and the function now returns false. And we can see that if this returns false, there is printing of hacking alert, and the program doesn't even get to executing the command. So I know that this line is the very line that I need to bypass at the moment. So right now I'm continuing execution of the program. I will set up a breakpoint inside this function. So I now have 2 breakpoints, and I will change my payload now to use backticks instead of the $sign. Right now I will again stop in this place, I tend to like remove the outer breakpoint because I set up one here, so I can remove this one, or I can only disable it, and I can continue again, and it now stops in my next breakpoint. It breaks, you could say, and I will do the same thing as previously. So I'm stepping over until I get to this check where it returns false again, because the code also checks if I have backticks in my code. So I will continue again, and I have to think about a payload that does not include backticks or dollars. So I will go for another vector here. I will try a semicolon, and let's do the same again. And this time I don't have this breakpoint. This one is deactivated, and I am in this is secure function, and I will step over until I get to any return false fragments. Turns out I don't. Turns out we get to the very end of the function when it returns true, which means it is secure. So I can now step out of this function, and again we are in this place. I know that I can bypass this is secure function, so I will now deactivate this breakpoint as well, collapse this function, and continue execution of the program. But I see that it doesn't really execute the ID command. It echoes the string ID, which is definitely not what I wanted. And I have a feeling that the filter malicious function may have something to do with this. So what I will do is I will put a breakpoint here, and I will start the program again. And we can see that up until this point, our parameter is not changed. It's exactly the same what it was here. But if I step over this function, I can see that all of a sudden the parameter is ID, but the semicolon is not there. So it's nothing strange that it only prints the ID string. So what I would like to do is now step into the filter malicious function to see what this one does. And we see that it checks if ampersands are in our payload, but they are not. And then it checks if the semicolons are, and in this case there are, and it's a while loop that removes all of them. So if we step over this, we see that we indeed step into this block, and the semicolon is removed from the payload. So we need to find a payload that also doesn't use the semicolon, and this is the one that I could use with the pipe. And right now I will continue the execution without stepping into, and finally we can see that the payload worked because the ID command was executed. And important thing is that in this case, this program didn't take any arguments. It didn't require any libraries, environment variables, nothing like this. And so I could just debug Python file, and it worked because it executed the command without any arguments. But more often, when testing any more complex application, you will need to either configure some arguments, some parameters, environment variables, things like that. And for this, in VS Code, you will need a launch.json file. And in the left-hand side menu, if I choose Run and Debug, I see that I have no configuration, and it allows me to create a launch.json file. So I do this, I choose the first option, a Python file. There are also pre-configured files for frameworks like Django or Flask, but in this case, it's just a Python file. And it looks like this. It generates the program, and I am able, and I will show you that in a few slides, I am able to configure it, for example, environment variables. So we'll jump to this in a second. For now, let's come back to the presentation. So this is the comparison of different ways to approach testing open source application. The first one, the most common, I think, is just analyzing the source code statically. Importantly, I am not talking here about using any tools. I'm just talking about a manual source code review, or manually working with application than we have source code access to. So static code analysis is the easiest one to start because you just need the code and you can browse it straight away. Then the next step, a little bit harder, is running the application. Then you need to maybe install libraries, set up the environment. If you are lucky, if the application is available as a Docker image, because then you can usually run it with a single command. And then the most advanced, I would say, way to test it is with the debugging setup, which is what I was just showing you. So it's running the application plus dynamically analyzing the code. And in my opinion, it is the most effective way to test applications because it combines the pros of static code analysis and running the application. And I think that it's better than static code analysis because when you're doing that, you need to first know what the functions are doing. You also need to remember the call stack in your head. You need to remember where you are and what will this code do. And I feel like static code analysis requires more knowledge of the language you're auditing than debugging the code, because when debugging the code, you don't need to guess what the function is doing. You can just step into it or step over the function and you will see the result. I'm answering this because people often ask me, do I need to know the programming language to either manually review the source code or to debug the source code? And I think that for both of these, you need to understand some programming language. One is usually enough, and then you can review the source code of other ones. But I would note that, in my opinion, you need less of this knowledge for debugging than you need for static code analysis. Running the application, of course, does not require you to know any code. You just need to be able to start the application. And usually you can also combine static code analysis and running the application. And a few years ago, what I would do is run the application, check the logs, check the database, maybe add some printing some variables to see what the values are, plus read the code. This is what I would do a few years ago because I thought that debugging is very hard. It's insanely complicated and I won't be able to do this. But this is really not. It's not that hard as I initially thought and as you may think as well. So when to do what? So even though I've said that debugging is the best way to do the source code reviewed or analyze the application that you have access to the source code, it also requires the most effort to configure. So I would not recommend to do it every single time. The source code review will be much better if you don't know how to set up the application, which is likely. Even though it's not insanely complicated, I also can't say that for every application it's easy to create to run the application. Also, if the application I'm analyzing is not complex, it's only a few hundred lines, I can get my head around the whole code base, I may also not go for the static code review. When it comes to running the application, I think these days I rarely do it because I feel like in these three levels, the effort between statically reviewing the source code and running the application is quite big. Installing the libraries, there are always some problems. And personally, I am a problem solver mentality, but it somehow does not apply to this kind of problems. And I absolutely hate fighting with machines when I need to install something. And I feel like for running the application, the effort is quite big. But then the additional steps to add the debugging setup, if I already have the app running, is not that big. So if I can already run the application, I prefer to invest a bit more and just have the debugging setup, which is my definitely go-to way to analyze the application if I want to dive deep into it. And earlier I spoke about the launch.json file and now the practical example of how to do this, because if there is one valid argument against debugging, this is that setup might be hard. As I said, I personally hate doing setups. So the first thing you need to do before you even start thinking about debugging is to just be able to run the application without the debugging. These are steps to install Kibana. It's the Elasticsearch application. Doesn't really matter what it does. These are just steps from GitHub's README file, which you have to take. So you just clone the repository, choose the proper version of Node.js, install yarn, and then you run install KBN bootstrap. And I have no idea what this command does under the hood. It was created by the developers. They know what it does. I don't have to. I'm just worrying for it to not throw any errors on the way installing those plugins. And then to start the application, I have to first start the database. So this is the command to do this, Elasticsearch database. And then starting Kibana itself is this command yarn start run examples. And let's see how this translates to the launch.json file that I showed you earlier for the Python file. So this is the file. These everything apart from these two lines, or this last line actually, everything apart from that was generated automatically by VS Code when I clicked create launch.json file. Everything that I added here is runtime arguments to just use the start command and run examples, and that's it. And right now I can just press F5 and debug this application, which is definitely not a small one. And we'll now jump into the practical step-by-step explanation of the SSRF in Smokescreen. And what Smokescreen even is, it's a proxy. It sits between the Stripe server and the public internet. And when Stripe, who created the tool and open sourced it, when they want to send a request to an URL taken from the user, which by definition is untrusted, they don't do it directly, but they go through Smokescreen proxy. They just connect through the proxy, telling that they want to connect to, in this case, 1234 address. And then Smokescreen checks the list of rules that it has configured and sees if it should allow or block this address. You can configure both allow lists, block lists of both IP addresses and domains. In this case, it would allow such requests because this is pretty harmless URL. But in this case, if I would add a URL with the internal IP, Smokescreen would block it because it's basically for preventing SSRFs. So it would not allow this address. So Smokescreen is a tool to prevent SSRFs. It works as a proxy. And the setup that I have also relies on the extension for VS Code. This time it's Go application, so it's also Go extension to VS Code. And again, the same way, I just opened this menu, run and debug, created a launch.json file. I chose the first option to select launch package, and this is the file that was auto-generated. So this is what VS Code created, and this is my actual file that I was testing the application with. So there are a little bit more changes because first it was program file dir name. It means the currently opened file, which is definitely a bad way. Don't do this because you would have to have the main.go file opened at all times. So I changed this expression to just hardcode the main.go file, and I also added the environment variable go 111 module on, and I also added some arguments with my config. The config that I have is a deny list that is supposed to block requests sent to example.com domain. And we'll jump to the practical example. And the first step when you want to debug an application is to identify the entry point. If it's a web application, usually you are looking for a router of a particular endpoint. So I would just search for it using the endpoint's name or something like this. Another way is just to trace what happens or find by a function name. In this case, there was a function called check if request should be proxied function, which sounds like it might have to do something with filtering the traffic. So I simply put, and this function was in the smokestream.go file, so it was pretty much the main file of this whole program. So I put a breakpoint there, and this is the command that I used to test. So I'm basically using curl to try to connect to example.com, which should not be possible, and I'm going through the proxy. This smokestream runs on address 4750. So of course the program breaks in this check if request should be proxied function, but it actually doesn't do the domain comparisons that I'm caring for, but it calls check ACLs for request. This is actually very common, that whenever you are debugging something, first few function calls will usually not have the juicy low-level comparisons. It will be some higher level functions like check ACLs for request, and the actual comparison of domains, of IP addresses, of things like that will be a few calls down the line. So I stepped into this function. Check ACLs for request has some config, some logging, some metrics, but it also doesn't have the juicy comparisons. So, but there is a function called decide, which also does sound like something I would be interested in. So I'm stepping into the decide function. This one still doesn't have the comparisons, but it does one by one check different sets of rules. And the first set it will check is the global allow list, which I'm not interested in. Here I'm just inspecting what is the rule object in this first step, but I didn't like follow this lead. I just went over, and we can see that this first call to domain globs, host matches glob, checks if the host is on the whitelist of or allow list of domains, but I stepped over it because I only have the deny list configured, and this is the check of the deny list. And in this case, we can see that host matches glob function is called with host and DG variables. Right now I can also evaluate what are the host and DG values. I can see that on the left hand side panel. I can also evaluate it in the console. So let's step into the host matches glob function, and this one finally contains the juicy comparisons that I cared about. And there's an if statement because the domain glob, which is the rule specified in the smokestream config, it can also be a wildcard. So there is a check if that's a wildcard or not. But in my case, it's not. It's just a hard-coded domain. So when I step into this if, we go straight to the else if, and there is a simple equals comparison of domain glob, which is the rule, to the host, which is the URL that I'm trying to connect to. And to me, it immediately looked fishy because URLs are insanely complex. And having just a simple equals string comparison seemed like it can never work. I didn't come up with the solution straight away, but I came to that point later. In this case, my request is denied. We can see the 407 response code because the host matched the rule in global deny list. So this doesn't work. But as I said, URLs are really complex. And in this case, the trick that I could use is a trailing dot, because from DNS standpoint, if you have example.com with the dot at the end, it's just an absolute domain name. If you have example.com without the dot, it's a relative domain name. In our browsers, in most or probably all our tools, you can use both ways of writing the URL. But in this case, it wasn't exactly the same because the version with the dot at the end didn't match this equals comparison. So I set a breakpoint inside this function, so I don't have to step through all these check ACLs for request and so on. Usually in this case, I would also deactivate the outer breakpoint, but in this case, I didn't do this, so I stopped in check if request should be proxied function. So I had to continue the execution of the program until the next breakpoint, which is inside the host matches glob function. And we can see on the left-hand side that host indeed has the dot at the end and domain glob does not. The dot is not stripped at any point, which means that this comparison will not return true. So according to this script, those domains are not the same, which means that the deny list rule will not be matched and the request should be allowed. And as I continue execution of the program, we can see in the terminal that indeed I have the response from example.com domain, which means I successfully bypassed the deny list. As a result of that, I got $1,500 from Stripe, and also it was assigned a CVE. It's the first CVE that I got, which, to be honest, didn't change anything in my life, and as I didn't expect, but it's something that at least looks nicely. So what is my approach when testing for these bugs? First, I know that one of the common ways to do the source code review is to just look for dangerous functions, for functions like eval, exec, and things like that, looking to catch the low-hanging fruit. Personally, I didn't do this. The reason is that I'm spending most of my time at the moment on public programs from HackerOne, and I'm not deluding myself that I will just find a simple eval call and I will find an RCE this way. I am, however, using two tools that I hope that would catch those things for me if somehow they happened. It's CodeQL, which I use through LGTM website, which is a very good scanner. It has really nice findings and often gives me some leads as to what should I look for in the application. And the other is SemGrep, which is a little less sophisticated, which doesn't mean it's worse. And I hope these tools would catch the low-hanging fruit for me. But what I do is I just start the test like I would do a black box. So I'm just finding a functionality that seems interesting, and then I try to find the code responsible for doing this. I set up breakpoints and I try to understand what are the parameters, what are the sources saying more appropriately, and then what are the things, which means what can I do with those parameters, what potentially can go wrong. And that's basically what I do. And regarding finding the place in code, there are two tricks that usually work for me when I'm trying to find the code responsible for a functionality. The first one is looking by the endpoint's name. So when you are looking for, let's say, password reset functionality, the code responsible for that, and it's on /API/user/reset password endpoint, the reset password string must be somewhere in the source code, and it's quite a unique one. So what I would do is I would just look for this string throughout the whole code base, and somewhere would be the code that says that this is the code that will handle a request sent to this endpoint. And it works, I would say, in 80% of the time when testing a web application. The other one, which also is quite reliable, is looking by error messages. So when you have an error message, maybe in the browser, maybe in the JavaScript console, maybe in server logs, which you also have access to, the part of this error also has to be somewhere in the source code as a string, of course. So if you have an error, just look for part of this error throughout the code. I just use VS Code search functionality to look for these things, and it works quite well. And remember that part of the error message will be parameterized, will contain parameters. So you need to cut out to the part that doesn't have any parameters. And where to start? It's also a very common question that I get asked quite a lot, and I recommend starting reviewing the source code with CTFs. Why? Because first, those code bases are usually quite small. I of course mean web category challenges that have the source code available. These usually contain only a few hundred lines of code, like 200, 300 lines of code. So it's not overwhelming as, let's say, a big enterprise grade product. So they are quite small, and also they are available. You have instructions how to run them. So that's what I recommend for anyone who asks me where to start reviewing code or debugging the code. And there's a ctftime.org website which has all the CTFs that are happening right now. Actually, there is a NahamCon CTF going on. I'm not sure if the source code is available for the tasks, but if it is, I definitely encourage you to check that. And that's it for this presentation. Thank you very much for sticking with me, and I hope that for at least some of you, I really cleared that debugging is not that hard, but it can have a really great impact on your methodology, and I hope that some of you will want to know more about it and will incorporate this in your workflow. If you want to access slides from this presentation, here is the link, bbre.dev/dbg-slides. Here are my media. Those are clickable links which you can see if you can open the presentation. If you just want to open a URL, write bbre.dev, and there are links to all my social media that I have. And I also prepared a survey about this presentation. This is my first time speaking at NahamCon, and I would be very grateful if you fill this out for me with a feedback about this talk. That's it for now. I hope that you learned something from this talk and maybe you will start debugging your source code. Once again, thank you for today.